Hello everyone and welcome. This is the CyberSecStudy CISSP video bootcamp series. You're watching the free version of this domain. For access to the full version, go to the website at www.cybersecstudy.com. So hello everyone again, my name is Donald Parker. The reason you're watching this video is because you're interested in obtaining the CISSP certification, and in some cases you need it, right, for your job. The reason I'm here is because I developed a training program that can help you get past this doggone exam. So the program consists of a book of the course material, audio recordings of all of that content in the book. We have the video recordings now of all of the content of all 8 domains. I developed a Jeopardy style game that has questions that are based from the course material, and then a Kahoot competition style game where folks can compete and test their knowledge of the information in the course material. So this is a copy of the book. It's a little thicker than I really wanted it to be. But this is a hard copy version of the course material. If you purchase the audio or the video, then I'll also give you a soft copy of this course material. So for the book, it took me several years to write this book. I used several sources. The common body of knowledge, of course, the CBK is the most authoritative source. I also used the late great Sean Harris's all-in-one study guide. It's a phenomenal book. I used several practice question exam books that had explanations, very good explanations of key terms and concepts, and then the internet, of course. So I went through all these sources. I tried to group together the smallest grouping of terms that I thought would help you pass the exam. So I tried to, I categorized all these terms into either just terms, informational notes, concepts, and something I call muscle memory, which is all those algorithms and the OSI model and the ports and protocols and all that stuff that's just muscle memory that we have to memorize. I broke that out separately so that you could print out those muscle memory charts and focus on the muscle memory separate from understanding the terms and the concepts that I want you to know. So the focus of my book, of this course material, is to identify key terms and to expose you to those key terms in many different ways. I went through a couple of boot camps myself. I've taught boot camps with other people's course material, and what I've felt from those classes is that they were just throwing a bunch of information at you, just a ton of information. There's no way any of that stuff was sticking. So the intent of my program is to identify key terms so that when you're taking that exam and you're reading a test question, you see 3 or 4 key words, and those will point you to the correct answer. So we go through, as you go through this video series, you'll see these and hear these key terms. When we play rounds of Jeopardy, they're focused on these key terms. And when you test your knowledge with Kahoot, you're going to see these key terms again. So multiple times you're seeing these key terms and they're just embedded in your brain. So you could purchase the book, read the book. You could listen to the audio, which is just a verbatim, word for word illustration of the book. You can read or listen to the audio and follow along in the book at the same time. You could purchase the video series that you're looking at now, the full version of the video series for all 8 domains, which is the video recordings are a recording of a boot camp we just finished a couple of weeks ago. It turned out a lot better than I expected, and I think it can be really helpful. You could also watch or compete in rounds of Jeopardy, which, after you've gone through all the material and you're ready to see where you're at and test your knowledge, there are 15 rounds of Jeopardy to get through all 8 domains. But then Kahoot. Kahoot is something that we do on a weekly basis in the evenings. You could, if you go to the website and purchase the ability to compete in one of these competitions, there's one for each domain. The number of questions varies, but after you compete in this competition against other people who are preparing for the exam, it gives me a spreadsheet of every question and every answer, whether you answered wrong or right, so that I can sit down with you and know where you're weak and where you're strong. The people who compete well at Kahoot pass the exam the first time, every time. So the question that I often get, I think I get more often than any other question is, what's my success rate? How many of my students actually pass the exam? So I've been teaching CISSP boot camps with my own material for about 5 or 6 years. I've been teaching the boot camp for over 10 years, but all of my students pass the exam. If you go through my entire boot camp, I can tell you with the Kahoot rounds and the printout, the spreadsheet that comes out of that, I can tell you whether I think you're ready or not. If you're ready, you take the exam, those people pass every time. If you're not ready, I'll tell you, and I'll tell you what I think you need to work on. Now, I've had some folks who took the exam anyway, even after I told them that I think we need more time. They didn't pass the first time. I worked with them some more afterwards, and they passed the second time. So really, it's up to you. If you can get through all of this content, it's a marathon of material to get through. If you really want it, if you really need it, then if you can get through all of this content, I am very confident that you can get through the first time. But I would need to see you compete on Kahoot rounds in order to know for sure whether I think you're ready. All right, guys, that's it. Welcome to the program. Welcome to this journey to cybersecurity. It is the fastest growing industry in the world. It's the most exciting, in my opinion. I love what I do. I love working with this stuff. I love talking about it. I love sharing information. So again, if you're interested in the full version, go to www.cybersecstudy.com and take care.
All right, May 6th, security assessment and testing. A brand new domain to the 8 domain format, the only brand new domain to the 8 domain format. Instantly, my least favorite domain of them all. But, well, one thing I like about it is it's short. So we'll get through it pretty quickly. Play around with Kahoot and potentially get started at least on domain 7, but we'll see. We'll see how time goes. So security logs, we've talked about these already. Term number 434. Security logs, a record of the events occurring within an organization's systems or networks. You have all these different system components that are capable of generating security logs, like your routers, switches, your operating systems, databases, and some applications. But in some cases, you have to turn auditing on in order for them to actually start collecting these events. And then you want to configure them to only audit for the things that are of interest to you. You don't want to audit for everything. And if you can get an automated audit log tool or a SIM tool that can serve as a central repository where all your devices are forwarding their events to this central repository in near real time, you can turn on alerts to alert you of suspicious activity. And greatest weapon that we have, in my opinion. Security log management is the process of generating, transmitting, storing, analyzing, and disposing of computer security logs. When we get to start talking about the legal aspects of cybersecurity, we need to demonstrate that we're collecting these logs over time in order to present them in court. So if you've been in a role that requires you to review audit logs manually, I think Aaron, you said you were doing that. That is a painful process.
Yes.
Tedious and painful. It serves as compensation if you don't have an automated audit log tool. Not nearly as efficient and effective as an automated audit log tool, but at least you're doing something. All right, so let's talk about some forms of monitoring. We have real user monitoring, or RUM, which is an approach to web monitoring. It aims to capture and analyze every transaction of every user of a website or application. It performs a passive monitoring. We talked about the difference between passive and active monitoring, or passive and active attacks. Passive is just because you're looking at the traffic doesn't mean it's active. It's still passive until you perform an actual attack. Synthetic monitoring is website monitoring that's done using a web browser emulation or scripted recordings of web transactions. And behavioral scripts are created to simulate an action or path that a customer or end user would take on the site. So you're just going through the motions on these different sites to see if they perform the way you intend for them to perform. Those paths are then continuously monitored at specified intervals for performance. So you're looking at functionality, availability, response time measures. It's of value because it enables a webmaster to identify problems and determine if a website or web application is slow or experiencing downtime before that problem actually ends or actually affects your end users. Website monitoring uses synthetic transactions, which we just talked about, to check availability and measure performance of a web page, a website, or a web application. Database monitoring also uses synthetic transactions. It monitors the availability of a database. TCP port synthetic transaction measures the availability of your website, service, or application. You can specify the server and TCP port for the operations manager to monitor. And then now we're going to talk about testing. So a lot of this we've already touched on, and I'm pretty sure you guys are up to speed on. So black box testing. The tested system is used as a black box, as in there's no internal details of the system. You go to test the system, you're not given the source code, you don't know very much about the functionality of the system. You're just trying to see what you can find. White box testing takes the internal system details, such as the source code, into account. With dynamic testing, the system under test is executed and its behavior is observed. Static testing techniques analyze a system without executing the system. In manual testing, the test scenario is guided by a human, and then automated test scenarios are executed by specialized applications. Fixing bugs and security vulnerabilities late in the software development process is always costly, not very effective. You always want to start testing your applications or identifying bugs as early on as possible. Now for the software development lifecycle, I think we talked already about this term. Should it be software development lifecycle or system development lifecycle? For me, a software application is a system or part of a system. It's a system component. So we could use the phrase system development lifecycle to encompass anything, or we can be a little more specific in general and say software development lifecycle. So again, we want to start considering security as early in the development process as possible. That system I helped, I served as the ISSM for at an agency I won't name. They were considering bringing in this new system, this new application to consolidate all of their data, all the different databases, and they brought me in during the planning phase. And they're talking about consolidation, so I'm thinking of single point of failure. You want to start thinking about these things as early on as possible. So a security review of the architecture and threat modeling are important prerequisites for subsequent security testing efforts. A manual review of the product architecture to ensure that it fulfills the necessary security requirements can be beneficial because it leads to detecting architectural violations of the security standard. And then threat modeling involves structured manual analysis of an application-specific business case or use scenario. Second step of software development lifecycle is, and the names of these steps can be different for every organization you're in. But the second step can be application development. So you did your planning in step one, and now you're going to start developing, and this is where majority of the work takes place. This is where an application is not yet sufficiently mature enough to be able to be placed into a test environment. And then we have two different types of application development. We've got or review or testing. We've got source code analysis, analysis of the application source code for finding vulnerabilities without actually executing the application can be used to detect insecure programming, outdated libraries, and misconfigurations. And then binary code analysis, analysis of the compiled application's binaries for finding vulnerabilities without actually executing the application. Similar to the source code analysis, but not as precise. So when it comes to this, we're going to get to the software development domain here shortly, and I think a lot of these terms for folks that aren't software developers can be overwhelming, but this is essentially what we need to know. All right, the third phase of software development lifecycle is the executable in a test environment. At later stages of the development lifecycle, when the software can actually be executed, further testing and approaches can be applied. For example, you can have manual automated penetration testing, which simulates an attacker sending data to the application and observes its behavior, which can identify a wide range of vulnerabilities in the deployed application. Automated vulnerability scanners, we've got a lot of different tools out there that can scan. They're not really, well, the ones that I worked with, the team I worked with a few months ago, they used two different scanners and they produced different results with different names. It was hard to develop a risk matrix based on those findings from different tools that produce different results with different names. But you want to test an application for the use of system components or configurations that are known to be insecure. Predefined attack patterns are executed. System fingerprints are analyzed, which can help detect well-known vulnerabilities. And then fuzz testing, that word fuzz testing, if you've never heard it before, highlight it, make sure you remember it. Send random data, usually in large chunks than what's expected by the application, to the input channels of the application to provoke crashing and see what happens. Fuzz, it's almost like a deluge with physical security, with wet pipes. All right, I think we're on the fourth step here, system operation and maintenance. This is where the application is actually in production. During the operation of an application, the security testing techniques could include penetration testing, vulnerability or fuzz testing, a large amount of unexpected inputs. These can be applied to ensure that the system configuration is still secure and that assumptions are not violated accidentally. All right, once the prerequisite tests, for example, code inspection, have been successfully completed, software testing can begin. So let's talk about some of our testing methodologies. We can do unit testing, which is a software test method that where individual units of the source code are tested. So sets of one or more computer program modules, different parts of the program. If a program has multiple capabilities, you can develop just one module for one capability, and that module could function on its own, and then you can develop multiple modules. You don't want to be in a situation where you have to create all the modules in order for the program to work. It's dependent on all the other modules. So these things are tested to determine whether they are fit for use in unit testing, individual units. System level testing is conducted on a complete integrated system to evaluate the system's compliance with its specific requirements. Integration testing is a phase in software testing in which individual software modules are combined and tested as a group. So if you had different units or different modules, you did unit testing on them individually. Now you would group multiple ones together and see how they interact and how they work together. Interface testing is different from integration testing in that interface testing is done to check that the different components of the application or system being developed are in sync with each other or not. And then code-based testing is also referred to as structural testing, and we'll see that again. Structural testing is code-based testing. You actually get to see the source code. Structural testing can identify dead code that's never executed when the program runs. I remember that being one of the things that software vulnerability scanning tool would detect. Structural testing is accomplished primarily with unit level testing, but code-based testing is structural testing. We'll see that again. Coverage is another term that I heard working with these software developers. It represents the metrics used to evaluate the level of structural testing. Structural testing, we said, was code-based testing. So the metrics used to evaluate code-based testing that are designed to show what percentage of the software has been evaluated. So, and that's very key. Coverage is you're trying to determine how much of the code has been evaluated. What percentage of it has been evaluated? You want to know that at all times. You want to know when you get to 100%. Statement coverage, we've got different types of coverage, many of them, and I don't think it's important to know all of these different types. I think it's most important to know just in general what coverage is. But with statement coverage, this criteria requires sufficient test cases for each program statement to be executed at least once. With decision or branch coverage, each program decision or branch to be executed so that each possible outcome occurs at least once. It's considered to be a minimal level of coverage for software products, but decision covered alone is insufficient for high integrity applications. With condition coverage, it differs from branch coverage only when multiple conditions must be evaluated to reach a decision. So with branch covered, coverage, it's one condition, and with condition coverage, it's multiple conditions. Yeah, get around nice and quick.